और सेशन नंबर 10 शुरू करेंगे। इसके लिए मैं बुलाना चाहूँगी आपको बता दें कि हम पेपर नंबर 728 के बारे में चर्चा करेंगे। इन्फ्लुएंस ऑफ एग्रीगेट साइज एंड इट्स ग्रेडेशन ऑन द बिहेवियर ऑफ स्टोन मैट्रिक्स asphalt मिक्सेस बाय श्री विश्व विकास राउत जी से मेरी रिक्वेस्ट है कि वो मंच पर आए, सीनियर मैनेजर श्री। और तालियों के साथ मैं फिर से कह रही हूँ कि तालियों के साथ स्वागत करेंगे पेपर नंबर 730 डिजाइन compaction standard for thin lift bituminous layers for low volume roads based on field performance। इसके लिए मैं बुलाना चाहूंगी, हमारे साथ मौजूद हैं प्रोफेसर विष्णु राधाकृष्णन जी और डॉक्टर ए वीराघवन जी, फॉर्मर प्रोफेसर आईआईटी मद्रास से हमारे बीच मौजूद हैं। साथ ही साथ we will discuss 731 paper number 731 comprehensive evaluation of black spot identification methods case study by Shri Dev Singh Thakur जी। देव सिंह ठाकुर से स्वागत है आपका। मैं बुलाना चाहूंगी मिस्टर यश पांडे जी को ऑन पेपर नंबर 732 rehabilitation existing rigid using asphalt concrete pavement for Indian condition। इसके लिए हमारे साथ मंच साझा करेंगे मिस्टर यश पांडे। स्वागत है सर आपका भी।
Sir, come here.
और अब इस कार्यक्रम की औपचारिक शुरुआत करेंगे, यानी पुष्पगुच्छ भेंट के साथ किसी भी चीज की शुभ शुरुआत होती है तो वो अपने अंजाम तक बेहद खूबसूरती से पहुंचती है। इसके लिए मैं बुलाना चाहूंगी श्री यूके गुरु विठल जी को मंच पर, फॉर्मर चीफ सेक्रेटरी CRI साइंटिस्ट, माफ कीजिए, फॉर्मर चीफ साइंटिस्ट CRI, जो कि हमारे चेयरमैन और को चेयरमैन सर का वेलकम करेंगे बुके के साथ। थैंक यू सर। और अब मैं अगला सेशन आगे कंडक्ट करने के लिए इससे मैं रिक्वेस्ट करूंगी चेयरमैन और को चेयरमैन सर से। ओवर टू यू सर।
So, dignitaries on the dais, ladies and gentlemen, we are here for the technical session number 10, in which the 4 papers which were earlier published in Indian Highways will be discussed here, will be presented here. My co-chairman will sum up all these presenters and their ideas and concepts later on at the end of the summary. I welcome all the presenters. I welcome all the dignitaries. I'm honored to have Dr. Veera Raghavan with us. I will now request to commence with the proceedings. The first paper that will be presented before us is paper number 728, Influence of Aggregate Size and its Gradation on the Behavior of Stone Matrix Asphalt Mixes by Sri Vishwavikas Raut. He will be presenting the paper. To all these 4 presenters, I'll request them that we have a time limit. Earlier, people have encroached on us, but then, well, let us take 12 minutes for the paper, 3 minutes for the answers, questions, if any. At the end of it, you all know my mail ID, so you can mail the questions to me. I'll get the answers and I'll come back to you. Okay? Let us start with Vishwavikas, please.
Respected Chairman Sir, Co-Chairman Sir, learned authors, and esteemed delegates. I am Vishwavikas Raut, and I have with me my colleague Mr. Kiran Togunashi. We are from L&T Construction Research and Testing Center, and today we'll be presenting you on a topic which is not very new to India. It has been there in India since 2008, since the first code on SMA was published. So we'd like to share some insights on how the gradations affect the SMA properties. So we know in flexible pavements, the major distresses are basically rutting and fatigue, and we try to minimize, reduce, delay this kind of failures in pavements, usually by a sound design or by choosing pavement materials which are adequate for the purpose, and also ensuring good construction practices at site, and also the quality control needs to be taken care of. Uh, so one of the products which helps us to reduce one of these types of distresses, that is rutting, permanent deformation distresses, is stone matrix asphalt. Stone matrix asphalt basically began in Germany. It was first introduced in Germany in the 1960s. It is basically a gap graded mix with high binder content, and it is designed to improve the rutting performance of bituminous mixes. Typically, it has very high coarse aggregate content. It is greater than 70%, and fine aggregate act as fillers in them. In India, in 2008, the first guidelines on IRC guideline IRC SP 79 was released, and from then on, SMA usage has been quite evident in the flexible payment ecosystem. But now the guidelines have been revised in 2023 based on the inputs that we have received in last 16 years. So if you see the main criteria through which the SMA gains its strength is stone to stone contact, aggregate to aggregate contact, and that is possible only if we have a sound gap graded mix. If you see global SMA gradations, the typical nominal maximum aggregate size which affects the aggregate gradation ranges from 14 which is in Australia, which is the maximum size, and it goes as low as 5 in countries like Germany. But in our code IRC SP 79 2023, the gradation, the nominal maximum aggregate sizes are restricted to 19 which is used in the intermediate binder course, and also 13 which is used in the wearing courses, which typically has a layer thickness of 40 to 50 So that was the objective, that was the motivation behind our research work. Ki- Can we not reduce the nominal maximum aggregate size in SMA mixes in India? Can we not go down to 9.5, 4.75 If you go down to such lower nominal maximum aggregate size, what is the impact? And also in those aggregate nominal maximum aggregate size, what is the impact of different types, shapes of gradation curves on the properties? So we have done a small study on that. And also one of the reasons why SMA was not very popular, has not been very popular in India, is extremely high binder content. Of course, it is required to ensure the durability of the mix. But is there any way in which we can play around with the gradation and optimize the binder content without affecting any of the performance characteristics of the mixes? So this was our methodology. We have considered three different mixes, 13.2, which is there in our IRC SP 79 2023. We have also considered nominal maximum sizes of 9.5 and 4.75 to produce SMA mixes. In all these three mixes, we have used three different types of aggregate gradations: S curve, mid curve, and inverse S curve. I will discuss about this in my further slides. And what we have studied is basically the volumetric properties, which is the minimum requirement of IRCSP 79. We have also done mechanistic characterization of the mix, and also performance characterization in form of Hamburg wheel tracking test and moisture susceptibility and fatigue life testing. So these are the raw materials. We used coarse aggregates which are meeting the mode fifth revision and the IRC SP 79 guidelines. VG40 bitumen was used in this study. This study was done in 2022, where VG40 was also allowed. Then VG40 was also allowed in SMA mixes, and also we use cellular fibers which were meeting the requirements of IRC. So this was our laboratory investigation. In volumetric analysis, we have considered voids in coarse aggregate, bulk specific gravity, optimum binder content, and air voids, and VMA and VAB properties. In mechanical characterization, we had mass of stability and flow, tensile strength ratio and resilient modulus, and performance characterization was done by Hamburg wheel tracking test and 4-point bending test. So these are the gradation curves that we have used for 13.2, 9.5 and 4.75 mm aggregates. There were 3 curves which were used. One was the midpoint curve, which is considered to be the densest particle line. And then we have used a S curve, which is very popular among pavement practitioners because of its performance. And we have used an inverse S curve. So if I show you in a magnified way, the S curve had percentage passing of coarse aggregates to be finer and the finer aggregate to be slightly coarser. Inverse S curve was the opposite of it, and mid curve was the standard mid curve. So starting with the voids in coarse aggregates, what we observed was in the inverse S curve gradation, we found the lowest voids in coarse aggregates, which indicates that there was better packing when the gradation was changed from S curve to mid curve to inverse S curve. So the same gradation packing can be also observed in the bulk specific gravity. We saw the maximum bulk specific gravity obtained for all the nominal maximum aggregate sizes in inverse S curve gradation. Air voids, the better packing, better workability translated into better air voids. We can see the OBC optimum binder content that we obtained for inverse S curve was found to be considerably lower than what we got for S curve and the midpoint curve. Uh, the mechanical characterization was done by the moisture susceptibility test, and moisture susceptibility test also shows that inverse S curves performs better than other gradations. We can see here it was as high as 92 to 90% for inverse S curves, whereas the S curves and mid curves gave relatively lower tensile strength ratios, which indicates the moisture susceptibility or moisture related performance of the mix. We have also found out the resilient modulus of the mix. The resilient modulus values for SMA mixes are not stipulated in IRC 37, which basically is the design guideline for flexible pavements. It only gives BC and DVM mixes. So we have tried to quantify the resilient modulus of SMA mixes. It was little bit lower than what we get in our conventional VG40 DVM mixes. VC mixes should also be lower, but we can consider the same modulus in for our design. Here the modulus values were slightly lesser, but because of better packing in inverse S curve, we can see the modulus values are slightly higher than other gradations. So coming to the performance testing, we have done Hamburg wheel tracking testing. We saw in our previous slides that all our mixes met the volumetric and the mechanistic characteristics. But if you see here the wheel tracking test, there is a huge difference. We see a different picture altogether. Usually SMA mixes are supposed to be good in rutting, but what we found out was the inverse S curve, though uh, it it had low rut depth as compared to other gradations, but we found that even SMA mixes with midpoint and S curve gradations could show high levels of rutting. And if we see 4.75 mix had extremely high level of rutting. So though internationally uh, countries have graduated to lower nominal maximum aggregate sizes, but our study shows that it is susceptible to huge amount of rutting. Fatigue life with inverse S curve was found to be the lowest because obviously we saw the optimum binder content was lower for inverse S curve mixes. Hence, we could find this translated into lower fatigue lives of the inverse S curve mixes. Coming to the conclusion, we found that the inverse S curve gradation was found to furnish the most optimum particle packing, facilitating lower optimum binder content, better stiffness, and lower moisture susceptibility. The inverse S curve was found to have lower rutting potential as compared to other gradations. The fatigue life of SMA mixes with nominal maximum aggregate size of 9.5 mm was comparatively better than 13.2 mm, indicating better performance and service life. Uh, the laboratory results suggests that nominal maximum aggregate size of 9.5 mm can be also considered. But of course, this is a laboratory trial. Lot of field trials needs to be done to ensure that the performances are translated in at the sites. But but the initial starting is encouraging. And what we found that SMA with nominal maximum size of 4.75 mm is prone to excessive rutting and needs to be revisited further for its suitability for usage in SMA. So thank you very much for your patience, and I thank IRC for giving us this opportunity to present in front of this august audience. Thank you so much.
I sincerely thank Mr. Raut to finish everything on time. If you have any questions, please send the chits to me. I'll ask request now Dr. Veera Raghavan to present his paper. Paper number 730, Design Compaction Standards for Thin Lip Bituminous Layers for Low Volume Roads based on Field Performance. Sir.
Chairman Mr. Joshi, Co-Chairman Mr. R.K. Jain, paper presenters on the dais and distinguished delegates. So what we are going to present today is about the design compaction standard for thin lift bituminous layers for low volume roads based on field performance. I will take you over what is that we are going to talk about as a thin bituminous layer, especially for low volume roads, and why the study is needed. So low volume roads generally in India are those roads which carry traffic less than 2 million standard axles. So what is the type of surfacing that we should adopt for these roads? From the PMGC website, what I could find is out of 17,39,275 kilometers of the core network, around 11.3 lakh kilometers are black topped. The question arises, what is this black top that can be recommended for the low volume roads? For a high traffic, say for example, within relatively, when you talk about the T9 traffic, the general recommended surface coursing wearing course is only premixed carpet. Or in some cases, depending upon the CBR, depending upon other criteria, it can be BM and a premixed carpet. As everyone is aware, this is called as an open graded bituminous premixed carpet. And then we construct an open graded layer and then seal it with a seal coat. Then we feel that this layer will perform better. It is cheaper. When we have got truth in the understanding that this layer is thin, village roads do not carry traffic, this open graded mixes will work. Whenever we require a thick layer, we recommend a bituminous macadam, hoping that BM plus PMC will work. But both are open graded. As you all aware, there is no mixed design. The check is only on the gradation. Second, only check can only be the binder content. As the layers are open graded, they are subjected to moisture induced damage. What we have done in the specification is that in the seal coat, there can be type A seal coat or a type B seal coat. Type A seal coat is generally preferred in a high rainfall area. Type B seal coat, the premix, is generally recommended for relatively low rainfall regions. But whatever is the seal coat that you provide, the underlying layer is open graded, has high voice, subject to moisture induced damage. So the question arises at this point of time is that instead of these open graded layers, can we provide a thin, dense bituminous layer? Can it replace this open graded premise? That's the question at this point of time. Is it cost effective? Is it sustainable? Will it have a lower life cycle cost? These are the questions that are posed before at this point of time. Generally, there's a feeling among the many of the engineers whom I have come across is that India is a poor country. We cannot go for dense bituminous mixes. They are very costly. So I'll bring to you these thin surfacings with a premise carpet. This is the condition. Thanks to Jaya and Kavita who are here. They evaluated the performance of this premise carpet, not only by them, but India as a whole. We studied by a pan-India study, NIT Kurukshetra, IIT BHU, MNIT Jaipur, SGS Institute of Technology, Indore, IIT Patna, NIT Trichy, as well as Rasta, Bangalore. We have evaluated 116 sections in 365 kilometers. And we found that these sections generally reach this stage. So how is the residual life? You'll find that you construct this PMC or BM and a PMC, they reach the stage of PCI within 50 within a year, 4 to 5 years. And moreover, the condition is awfully bad. So the question at this point of time, how will a dense mix will perform? If you look at the cost comparison, finally what we say is India is poor, we cannot afford bituminous concrete or dense mixes. If you look at the cost, I collected the data from Andaman Nicobar to Andhra Pradesh to Arunachal to Assam to Maharashtra. We find that cost of premix carpet is not cheap as we think. The cost comes to around 200 rupees to 225 rupees. In some states, is 437. When you compare the cost of a BC of 25 millimeter, cost is comparable. If you want to compare apple to apple, 20 millimeter to 20 millimeter, you will find that BC is relatively same cost. Not. You can also go to other states, Odisha, Punjab, Rajasthan, Tamil Nadu, Telangana, Uttar Pradesh. You can find any state for that matter. The cost of 25 millimeter BC is comparable to that of 20 millimeter premix carpet with a seal coat. So the issue at this point of time in Tamil Nadu, when you compare, the cost of premix carpet is 15.25 lakh per kilometer. The cost of BC is only 15.57. Now understand, BC is not costly. What are the other implementation issues? That's what we should talk. So the need for the study is that, as per the MS2, the compaction level for a marshal on both ends for a traffic less than 10,000 is around 35 blues. A medium traffic, which they say between 10,000 to million, they say 50 blues. And for a higher traffic, they say it should go for 75 blues. I tried to introduce that in IRC 111, but engineers did not agree for that. They say that heavily overload trucks, it will wreck, all the stories they told. Finally, I could not introduce that in the new 111. But what happens is that in the case of low volume roads, because traffic is low, when you compact them initially to 7 to 8%, they do not reach the 4% voids to the end of the design life. The voids remain at 5 or 6. When the void becomes high, it becomes pervious. It is subjected to cracking. It is subjected to moisture-induced damage. So what we are trying to tell is that do not compact the low volume road between concrete to 75 blues. If so, what should be the number of blues? Vishnu will answer that question. Second, these layers will not reach 4% voids at the end of design life. If so, what should be the desirable compaction standard for low volume roads? We have studied the performance of thin layers of 30 millimeter with BC. Vishnu will present what are the lessons that we have learned and what is the way forward. Yesterday, in the council meeting, IRC 111 has been approved. We have introduced new specifications for BC of 30 mm, 25 to 40 millimeter. You can use for 30 millimeter with a 9.5 millimeter nominal maximum aggregate size. This can be used for urban roads. This can be used for rural roads. This can be also used as a preventive maintenance treatment. So a new specification has been introduced that will also now answer your question. What should be the bituminous layer for thin low volume roads? So I stop at this point of time. I request Vishnu to take it forward as what we have studied. Over to you, Vishnu.
Thank you, Professor. Now, let me continue the presentation. So we need to understand in any mixed design, what does the compaction effort simulate? Now, if you see Marshall mixed design as well as Superpave, basically your compaction effort is expected to simulate the primary and secondary compaction that the mixes are likely to undergo in the field. Now, as roads cater different traffic levels, it is very important that these compaction efforts should be a representation of the traffic level. Now, it is very important when we design these mixes, these traffic levels has to be represented appropriately. Now, if you see the design standards, say for example, if you see Superpay mix design, the initial Superpay mix design which came in 1996, you could see that the design compaction effort was given as a function of traffic level as well as temperature. Now, later when they revised it, this was given as a function of traffic level. Now, if you see the original Marshall mix design, which came in 1930s, you could actually find that there also it was a function of traffic level. But when we adopted this in Morth, we are actually designing all our mixes by applying 75 blows of compaction. Now, when we are trying to adopt dense mixes for low volume roads, it is very important to see the densification characteristics of these mixes. Now, so the objectives of the study is defined as to evaluate the densification characteristics of dense layered bituminous mixes when placed as thin surface course layers in low volume roads, to estimate the design compaction efforts for designing dense layered mixes as surface courses in low volume roads, to evaluate the implication of lower design compaction effort in terms of the primary compaction, what happens. And the fourth objective was to compare the laboratory performance of dense grade bituminous mixes designed by the compaction effort what we determined in our study and with the conventional 75 blows. Now we have two sets of analysis. For the first set, we actually had laboratory studies where we collected field cores from sections where dense grade bituminous mixes was implemented. So there are two states in India which has actually implemented dense grade bituminous mixes. One is state of Telangana in their PMGSY projects, as well as in their ODRs and MDR roads. And the state of Kerala in Rebuild Kerala initiative, they've also implemented dense grade bituminous mixes of 30 lift thickness. Now, the second part of the study was basically laboratory investigation, trying to understand the implication of how does this reduced compaction effort will have on the mixed volumetrics as well as on performance. Now, let me briefly explain this. So, in the state of Telangana, in ODRs and MDRs, they have actually started constructing these dense mixes from 2018. So we took field cores from Khammam district, where the roads were of the age of about 4 to 5 years. So we sampled 15 roads, and from Warangal, we took 7 roads which was having an age of 1 year. And from Kerala, we had 7 roads again taken, which was having an age of less than 1 year. Now, let me actually explain you what is a pattern of coring what we did. We didn't had an initial information what was the initial air voids to which what these mixes were initially compacted. So what we did is we had two sets of cores collected. The first core was actually collected from the pavement edge, that was nearly to 0.5 meters from the pavement edge. The second one was taken from the wheel path. Now, for the cores which are collected from Warangal as well as from Kerala, these cores were collected at 0.7 to 1 meters from the pavement edge. Now you could actually see the air voids of this. So you can actually see if you see the field cores of, or if you see the air voids of the field cores taken from the edge, you could see the air voids in the range of about 8 to 9%. The the first figure what I'm presenting here. But whereas from the wheel path when we are taking, these mixes have only undergone a densification. It was only having air voids in the range of about 6 to 7. So what we need to understand is when we are actually placing these dense mixes, and that too designed by 75 blows, these mixes are not undergoing significant secondary compaction. Now this will have implications. Now in the second figure, you could actually see that the implications of what is the initial densification, what happens to the mix if the mix is designed by applying 75 blows and by applying 50 blows. Now the cores in Warangal, they were designed by applying 75 blows, but whereas what we collected from Kerala, these mixes were designed by applying 50 blows. So you can see here the mixes which are designed by applying 50 blows, they had lower initial air voids. Now we then examined the distribution of air voids. So you can actually see here over a period of 5 years, over a period of 5 to 6 years, the air voids were reduced only from 8% to about 6.5%. These were the roads which were in service for about 5 to 6 years. Now the second, and when there is no traffic moving on these roads, these mixes will remain. Now as they remain open, they will undergo excessive aging. Now to understand this implication, we carried out ideal CT experiment. So you could see that the ideal CT values of the cores what we collected from Khammam was in the range. The mean value was in the range of about 21. Now this has a high propensity for cracking once traffic starts moving on it. But whereas if you see the ideal CT values of the cores which were collected from Kerala, this was coming in the range of 100. This is because these mixes have relatively higher binder content. Now to identify the design compaction effort, what we did was we collected these field cores, we loosened these mixes, and we got the white rock aggregates. Now these white rock aggregates were compacted by applying two binder contents, one which was 5%, other one was 5.5%. So you could see that the cores from Khammam had a mean air void of 5.3. Now, what we were looking into was what is the number of compaction effort which can actually simulate the air voids in the field, and we could identify that nearly 46 blows of compaction can actually simulate the degree of densification what these mixes undergo in the field. Now, to understand the implication of this reduced compaction effort, we carried out volumetric and performance tests on mixes having NMAs of 9.5. We had 5 aggregate gradations for which we designed these mixes by applying 45 blows as well as the conventional 75 blows. So I'm winding up. Yeah. So you could see here, when we are designing these mixes at a reduced compaction effort, obviously your binder currents will be on a higher side. But we have improvements in terms of the flexibility index. If you see the volumetric parameters, you could actually find that the volumetrics, the VMA parameters are improved. And if you see the film thickness of these mixes, this is in the range of about 8 to 14 microns, which is desirable. Now we also carried out performance tests by carrying out ideal CT and dynamic creep tests. So you could see here, when these mixes are designed by applying 45 blows, the ideal CT index of these mixes were improved. And these are our conclusions. Now mixes which were designed by applying 75 blows, they left relatively larger voids. So it is very important to design these mixes at a reduced compaction effort. Mixes which are designed by applying 50 blows of compaction had improved placement characteristics in terms of reduced air voids. Now you could also see that the ideal CT index values of the field course what we collected from Khammam was relatively low. This actually shows signs of higher propensity for cracking. Now the study recommends 45 blows of Marshall compaction on both the sides for designing dense mixes for low volume roads. Now comparative analysis showed that when you design mixes by 45 blows, there is an increased bitumen content. Now this becomes a concern for everyone. Now, if you want to continue to design these mixes by applying 75 blows, it is important that you compact these mixes to reduce voids. That means initially when you compact this, you have to compact this to an air voids of about 4 to 5%. Now, this can become challenging. This has to be quantified. Now, we would like to thank NRIDA for funding this research project to NIT Warangal. Thank you.
Thank you, sir. We will now have a presentation about paper number 731, comprehensive evaluation of black spot identification methods, a case study. I request Sweet.
Hello, I am Dev Singh Thakur from Triple IT Hyderabad. Good afternoon to all chairpersons and all respected delegates. So, my today's topic is comprehensive evaluation of black spot identification methods. So, it's a case study that we have done on one of our crucial NH corridor, that is NH 44 from Hyderabad to Adilabad. And these are the author of this paper. And this study is a part of Project Rasid Telangana, and these are the consortium partners. So these are the contents of this presentation. It starts with the introduction, then literature, then objective and like this data analysis and results and conclusion. So let's start with introduction. So as we all know, road safety is a major concern for globally and our Indian country also, and where road crashes are increasing year by year. And so as we can see from the latest Morse report, road crashes are increasing year by year, and in year 2022 we have around more than 4.6 lakh road crashes and 1.68 lakh fatalities, and it has increased. Our road crashes have increased 11.9% from last year to current year, and fatalities also by 9.4% and injuries 15.3%. So to rectify these road crashes or address this road crash issue, mostly all the roading agencies identifies the black spots. That is basically a high risk potential areas in our road network in terms of intersection or mid block or any high risk corridors. So black spot is a road segment or location is known for disproportionately high crash frequency of crashes or fatalities. It may be due to various factors like road geometry, human factors, traffic, and environment also. So in India and internationally, we have many methods to analyze the black spots and identify black spots. Where some of our statistical analysis, crash rate analysis, risk mapping, GIS analysis, and road safety audits, and etc. So these methods will introduce some inaccuracies in the results, like in the outcomes of black spot identification analysis, that leads to generating some false positive and false negative results Like if we false predicted the black spot, but actually the results is not good. So like this, which hinders the understanding of high risk locations. Second, this is the traditional protocol for black spot identification that we were using before year 2022. So this was published by Morth, Ministry of Road Transport and Highway, in the form of a circular in year 2015. So it defines location or stretches as a black spots where 5 road crashes or 10 fatalities have occurred within a 500-meter road segment in the last 3 years. So last 2 years ago, IRC 131 has introduced IRC 131, which showcases the guidelines for the identification and rectification of the black spots. They introduce around 4 to 5 systematic processes for black spot identification that which are aligned with a safe system approach and multiple international standards. It includes first annual average total crashes method with a setting direction level approach. Second is heat map analysis and corridor analysis. Fourth is a severity index and severity indices method. So these are some previous good literatures where researchers have utilized multiple attributes for identifying the black spots and its rectification. So they have mostly utilized the historic records and their vehicle involved and demographics of the victims and road geometry information and traffic informations. Also, some authors have utilized the public opinions and expert opinions and road geometry and traffic parameters. So based on the previous studies and literatures, we have set objectives like comprehensive evaluation of all the methods present in the India, like traditional and in IRC 131 methods. And secondly, comparison of the traditional approach with that the integrated approach of proposed in IRC 131 for black spot identification to examine their methodological diversity, consistency, and suitability for identification. Third, to assess the most influential road geometry parameters for the incidence of road crashes and development of a crash prediction model. So this model will be mostly based on the road geometry part. So this is our methodology for our study. First, it starts with data collection, where we have collected a road inventory data in the form of geometric details. And second is road crashes data. Then we have developed a GIS database. And third, we have applied then traditional IRC 131 approaches. After that, we have developed a crash prediction model and further validated the results through RSA, road safety audit. So to do the study, we have selected one study area from on NH44 that starts from Hyderabad outer ring road to Adilabad city. So this is a 290-kilometer road network of in National Highway 44 situated in Telangana state. So this corridor has a 4-lane divided partially controlled access highway with multiple median openings in less than 2-kilometer interval. It includes 282 3-arm intersections, 173 4-arm intersections, 188 median openings like this, and also 155 curve regions. And this test corridor has limited service road about around 30 kilometers only, mainly at some of the habitation areas with minimum connectivity. So to conduct the study, we have collected two kinds of data. Firstly, we have extracted all the road geometric details from the prepared test corridor that we have developed using the Google Earth and Google Maps and further improved through QGIS software. From the test prepared corridor, we have extracted multiple road geometric parameters like road width, curve regions, including horizontal and vertical both, intersections, 3-arm, 4-arms, and presence of median openings. Secondly, we have collected the road crash data, historic crash data from NHAI of last 3 years from year 2022 that totals around 1504 road crashes, and these are the claimed fatalities and injuries of this test corridor. So to showcase the collected data, we have developed some distribution of the collected data over the entire test corridor. So from the first figure, you can see the road width distribution over the entire test corridor. Then second, 4-arm distribution over the test corridor, like this 3 arms and median openings and curve regions. So as we can you can see from these figures, mostly 3 arms and 4 arms intersections are present at the starting regions of this test corridor. And this sixth graph shows the distribution of total road crashes over the entire test corridor, where you can see the from this 100 chainage to 150-kilometer chainage, most of the road crashes were happened. It may be due to the straight region present in this test corridor region. Yeah, that perfectly aligns with the our national trend of straight region road crashes. Then we performed some detailed crash data analysis, where we firstly analyzed the annual statistics of crashes, fatalities, and injuries of all 3 years road crash data. So in the annual statistics, we didn't find any good trend, but you can observe this fatalities trend, which has increased from year to year, from 2020 to 2022. Fatalities has increased. Secondly, the crash severity index. So from that were calculated using the formula provided in the Morth report, which is fatalities per 100 road crashes. So from year 2022, the crash severity index has increased from 19.81 to 24.84. Then crash statistics based on road section type. So from the third graph, you can see that most crashes were happened on the mid block regions. That perfectly aligns the national trend of straight region road crashes. And lastly, the positive factors for the road crashes. So in this test corridor, mostly crashes were happened due to overspeeding and wrong side driving. That was basically due to lack of provisions of road geometric features like VUP, SVUP, and SVUP. And third is vehicle out of control due to varying terrain in horizontal and vertical directions. After that, we have done some we have prepared road crash metrics based on vehicles involved. So we have developed comprehensive data on vehicle road users involved in for these road crashes. So we observed mostly goods vehicles, two-wheelers and cars, and unknown vehicles and objects, static objects were involved in these crashes in this test corridor. After that, data analysis and results. So data analysis starts with the segmentation of the test corridor. So as mentioned in the IRC 131 and Morse protocol. So we segmented our study corridor into 500-meter segments, and thus a total of 584 segments were considered for the analysis. And for a specifically corridor analysis method of IRC 131, the study corridor is empirically segmented into 10 equal segments, as no segmentation method is present on IRC 131. Secondly, the creation of GIS database. So to perform the analysis, we have developed a GIS database in the QGIS software, where we have incorporated all the road geometric details and road crashes information, including fatalities and injuries, and 3 arms, 4 arms, etc. After that, we perform identification of black spots. So from the first traditional approach, uh, basically the Morse protocol, using this approach, we have identified 109 locations based on the 5 road crashes or 10 fatalities definition, and prioritizing them by arranging segments in descending order. Secondly, identified black spot based on the reported numbers and crashes and fatalities only. Second method of which are of IRC 131, annual average total crashes method with setting reaction level approach. So this method's objective is basically identify crash prone and black spots by calculating annual average total crash value. So this is a new term for our black spot identification analysis across in all road categories. And this is a procedure for calculating AATC per 500-meter value. So where we have to first collect the fatal crash data of all road type and state. Then we have to calculate the road length for each road category. Then we have to calculate AATC per kilometer value. And lastly, AATC per 500-meter value. So the process to identify black spot using this method is, firstly we have to calculate the AATC per 500-meter value for all kinds of road network and state type, and then identify black spot as 500-meter segments where crashes were exceeding by as compared to AATC per 500-meter value. Then after identification of black spot, to categorize these identified black spot, we have to use the setting reaction level approach, where first order black spots are where AATC or crashes value exceeds 15x of AATC, and second order black spots where crashes have increased from 10 to 15x of AATC. Likewise, the third and fourth order black spots will be calculated. And these are the outcome of this method, of this first method, AATC method, where we have identified total 219 black spots, up to, if you consider up to fourth order black spots. And if you consider only up to third order, then total 109 black spots were identified. Yes. So, interestingly and surprisingly, this 109 black spots up to third order severity category is perfectly aligning with the traditional approach method outcomes. And also to validate the this alignment with the traditional approach, we have validated with other two additional NH corridors, where in Hyderabad to Pullur corridor and Hyderabad to Kodad corridor, where we also seen that the outcomes of this AATC method up to third order severity category was perfectly aligning with the more or traditional approach. So it is evident from the above comparison that AATC method is more scientific than traditional approach, and it's prudent to consider up to the third order severity category for black spot identification. Second method of IRC 131 is heat map analysis, where where we can identify crash hotspots using the geospatial analysis using the GIS softwares. So here we need to import all the test corridors and road crash data into the GIS platform, and we have to apply some kernel density estimation methods like point density estimation to identify the crash hotspots. It will give some hotspot with varying colors, like warm colors give the high density crash regions, and cooler colors gives the low density crash regions. So we have categorized these hotspots into three categories based on its severity: severe, moderate, and mild. Third is corridor analysis. It is mostly similar with the heat map analysis. So here we have segmented our test corridor into 10 segments empirically and applied line density estimation to identify the most severe segment in our test corridor, where segment 5 is the most severe segment we have identified. This is the fourth method of severity indices fourth method of IRC 131, that is a severity indices method. So this method is only proposed in the IRC 131 to prioritize the identified black spots for their rectification and remedial measures work. Using these weights, like for fatal crashes, weight is 10, for major injuries 5, minor injury crashes 2, and no injury crashes 1. So these weights are only for prioritization of the identified black spots. But from our study, we are proposing this weights to for the identification of black spot also, using the following process. Like firstly, calculate the crash severity index for each segment based on these weights, and second, calculate the mean severity index, then standard deviation, and thirdly, the threshold crash severity index using a normal distribution method with a Z score with a varying confidence levels like 95%, etc. Outcome of this method is 19 segments we have identified as first order black spots, and further categorization based on adjusted Z scores. Moreover, we have developed a crash prediction model, as we don't have any crash prediction model based on the road geometry parameters. So we have developed using these parameters like road width, curve regions, intersection, and presence of median openings. So we have developed a GLM model, generalized linear model, using a Poisson log linear approach, where we have find all these parameters are significant with the road crashes. This is our model for predicting the black spots based on the road geometry parameters, where all the parameters have good significance against the road crashes. These are our identified black spots, top 20 identified black spots from various methods. First, from traditional approach, ATC method, SI method, heat map analysis, corridor analysis, and lastly, the crash prediction model. And then we performed a comparative analysis of all these black spot identification methods, where traditional is our baseline method, where we only use crashes and fatality counts, and we have no any approach to categorize or ranking the identified black spots. Then AATC method, that 80% aligns with the traditional approach, but we have good ranking or categorization process, like setting reaction level approach. Then severity indices method, 75% aligning with the traditional approach and 55% with ATC, and ranks we will categorize all the identified black spots by TCSI values. Then heat map and corridor analysis methods will give only visual results.
We come to conclusions.
And these are the list of top 20 black spots. And we have validated these outcomes through road safety audit processes and we have perfectly audited, and all the outcomes are perfectly aligned with the ground observations. And these are some glimpse of road safety audit process during our study. These are the comparison of rank 1 black spots of AATC and SI methods. And this is the conclusion. So in this study, we have comprehensively analyzed the traditional approach and IRC 131 methods. And we have noted that the traditional methods have several limitations, like overlooking factors like road geometry and land use, that will lead us to false negative and false positive results. And we have noted that IRC 131 methods like ATC and SI are more reliable, considering considers multiple factors like classification based on severity, and identifies using the road length and state type category. And heat map and corridor analysis are mostly for visualizing high risk segments using GIS tools. And these are some 3 points of recommendation. So as per our international literatures and previous studies, for the identification of ATC black spots, we have to use up to third order. So third order ATC black spots should be considered for our effective analysis. And study also recommends using the SI method with weighted severity crash model to identify and prioritize black spots. And lastly, for high speed corridors, proactive measures such as conducting RSA during the operation and maintenance period for every 3 to 5 years are essential to maintain safety and to achieve the zero fatalities or vision to 2030. These are the references. This paper has been already published in Journal of Indian Road Congress. Thank you.
Mr. Thakur. Thank you. We have our last paper, which will be presented, rehabilitation of existing rigid pavement using asphalt concrete pavement for Indian conditions, by C. Sapan Kumar Bagwe.
Good afternoon, everyone. First of all, I would like to thank IRC to give us the opportunity to present on rehabilitation of existing rigid pavement using asphalt concrete pavement for Indian condition. Uh, अब हम सभी जानते हैं कि कंक्रीट पेवमेंट की जो डिजाइन लाइफ होती है वो 20 से 30 साल तक की होती है, पर ड्यूरिंग कंडीशन और ड्यू टू सम एनवायरमेंट इफेक्ट और ट्रैफिक कंडीशंस कंक्रीट में बहुत टाइम पे क्रैक्स आ जाते हैं या उसमें डेफिशिएंसीज आ जाती हैं, तो जिसके कारण उसका फेलियर होना चालू हो जाता है, जो कि किसी फंक्शनल कारण भी हो सकता है फेलियर का, या फिर एक स्ट्रक्चरल डेफिशिएंसी भी हो सकती है उसमें। तो इन स्ट्रक्चरल डेफिशिएंसी या फंक्शनल डेफिशिएंसी को ट्रीट करने के लिए अभी तक हमारे पास रिजिड के ऊपर रिजिड ओवरले का ही फिनोमेना दिया हुआ है कि रिजिड को रिजिड के साथ ही ट्रीट करेंगे, पर रिजिड के ऊपर यदि फ्लेक्सिबल ओवरले यदि हम डालें तो उसे किस तरीके से ट्रीटमेंट कर सकते हैं, तो इस चीज के लिए ये पेपर डील करता है। अब फर्स्ट ऑफ ऑल, इस बिटुमिनस ओवरले की नीड क्यों है? यदि हम लोग एग्जिस्टिंग रिजिड पेमेंट यदि स्ट्रक्चरली डेफिशिएंट है और यदि किसी कारण से ट्रैफिक को कैटर करने के लिए नहीं कर सकता, तो हम लोग उसको फ्लेक्सिबल ओवरले के साथ ट्रीट कर सकते हैं। अब इससे बेनिफिट क्या होगा कि फ्लेक्सिबल ओवरले के कारण हमें स्मूथ राइडिंग क्वालिटी मिलेगी, उसका स्किड रेजिस्टेंट इंप्रूव हो सकता है, हमें प्री ओवरले ट्रीटमेंट कम करने पड़ेंगे, जल्दी से जल्दी कंस्ट्रक्शन किया जा सकता है और कॉस्ट इफेक्टिव है विद इन कंपैरिजन टू कंक्रीट ओवरले। अब इसमें ऑब्जेक्टिव क्या है हमारे पास? यदि हम इंडियन कंडीशन की बात करें तो हमारे पास इंडियनाइज गाइडलाइन कोई सी भी नहीं है, तो हमारा ऑब्जेक्टिव है कि एक जो इंटरनेशनली अवेलेबल प्रैक्टिसेस हैं हम उन सबको एक बार इकट्ठा कंपेयर करें और एक इंडियनाइज गाइडलाइन को प्रपोज करें। अब यदि हम लिटरेचर रिव्यू की बात करें तो हमारे पास एक IRC SP 17 था 1977, जो कि इम्पेरिकल डिजाइन अप्रोच से बिटुमिनस ओवरले का हमें बताता था कि कंक्रीट के ऊपर कितना बिटुमिनस ओवरले की थिकनेस रिक्वायरमेंट रहेगी, पर जो कि अभी रिवाइज हुआ 2019 में, तो ये वाला सेक्शन उससे स्किप कर दिया गया, हटा दिया गया, क्योंकि वो कोड अब डील करता है कंक्रीट ओवरले विद कंक्रीट पेमेंट। सो हमें एक अलग से एक इंडियनाइज गाइडलाइन की जरूरत है जो कि इस चीज को डील करे। ये हमारा 1977 का IRC SP 17 कोड था। ये डेडिकेटेड इंटरनेशनल गाइडलाइंस अवेलेबल है। अब यदि हम बात करें कि जो सबसे हमारी इंडियन पेवमेंट की गाइडलाइंस जो है वो सबसे ज्यादा इफेक्ट को हुई है आस्टो MEPD गाइडलाइंस से। आस्टो MEPD गाइडलाइन जो डिजाइन के लिए अप्रोच बोलती है कि आप सबसे पहले एग्जिस्टिंग रिजिड पेवमेंट को इवेल्युएट करो, उसकी डिस्ट्रेस मैपिंग करो, उसका FWD एनालिसिस करो, उसमें यदि कोई रिफ्लेक्शन क्रैकिंग के लिए जो भी मिटिगेशन के अप्रोच हैं उन्हें देखो, और उसके बाद डिसीजन लिया जाएगा कि आपको उसमें ओवरले किस तरीके का प्रपोज होगा, फंक्शनल कैटेगरी का होगा या फिर स्ट्रक्चरल कंडीशन का होगा। अब रिफ्लेक्शन क्रैकिंग की बात करें तो कंक्रीट पेवमेंट के ऊपर यदि फ्लेक्सिबल की कोई भी लेयर चढ़ाई जाए तो वो सबसे पहले रिफ्लेक्शन क्रैकिंग उस पर सबसे ज्यादा इफेक्ट करेगा, क्योंकि कंक्रीट रिजिड है और बिटुमिनस जो है वो फ्लेक्सिबल नेचर का है, और कंक्रीट में जॉइंट्स कटिंग होती है और जो जॉइंट्स डायरेक्टली रिफ्लेक्ट होंगे। तो सबसे पहले अब ये रिफ्लेक्ट किस तरीके से हो सकते हैं कि कंक्रीट में एक्सपांशन और कॉन्ट्रैक्शन होता है, जिसके कारण उसका जॉइंट मूवमेंट होता है, तो जॉइंट मूवमेंट के कारण क्रैक ऊपर मिटिगेट हो जाएगा, या फिर वर्टिकल मूवमेंट हो या फिर पैरेलल मूवमेंट हो जाए स्लैब्स का, तो इसके कारण बिटुमिनस ओवरले में क्रैक डेवलप हो जाएगा। तो हमें रिफ्लेक्शन क्रैकिंग को डेवलप होने से पहले उसका ट्रीटमेंट करना पड़ेगा प्रायर टू ओवरले। अब इस पेपर में फंक्शनल डेफिशिएंसी को कैटर करना नहीं किया हुआ। इस पेपर में हम लोगों ने उसे स्ट्रक्चरल डेफिशिएंसी को ट्रीट करने के लिए किस तरीके से हम डिजाइन अप्रोच अडॉप्ट कर सकते हैं वो डील कर रहा है। आस्टो एमईपीडी की गाइडलाइन जब डेवलप करी गई थी तो उन्होंने पेंसिल्वेनिया डिपार्टमेंट ऑफ ट्रांसपोर्टेशन ने आस्टो एमईपीडी की गाइडलाइन के बेसिस पे 11 डिफरेंट सेक्शंस बनाए थे, जिसके ऊपर उन्होंने एफडब्ल्यूडी का एनालिसिस किया, और उसके एफडब्ल्यूडी एनालिसिस से एग्जिस्टिंग लेयर्स का मॉड्यूलस बैक कैलकुलेट किया और डिजाइन को रिकमेंड किया। अब बेस्ड ऑन 11 डिफरेंट स्टडीज कंडक्टेड बाय पेंसिल्वेनिया डिपार्टमेंट, उन्होंने सबसे पहले एग्जिस्टिंग रिजिड पेवमेंट को अलग अलग 3 तरीके के मेथड से ट्रीट किया। उन्होंने उसको क्रैक एंड सीथ किया, दूसरा ब्रेक एंड सीथ किया, और एक रबलाइजेशन किया, और उसके बेसिस पर उन सारी मेथड से डब्ल्यूडी टेस्ट परफॉर्म किया, और उसके बाद उसका एग्जिस्टिंग लेयर्स का मॉड्यूलस निकाला। अब एग्जिस्टिंग लेयर के मॉड्यूलस को यदि दूसरा लिटरेचर हम लोग देखें तो 1987 में उलिजिस नाम के रिसर्चर ने लेयर कोफिशिएंट मेथड को इलास्टिसिटी मॉड्यूलस के साथ कोरिलेट किया, और एक एम्पेरिकल अप्रोच इक्वेशन डेवलप करी कि स्ट्रक्चरल नंबर इज इक्विवेलेंट टू 0.27 मल्टीप्लाइड बाय लॉगरिथमिक इलास्टिसिटी मॉड्यूलस ऑफ एग्जिस्टिंग पीसीसी, रबलाइज्ड पीसीडी और फ्रैक्चर्ड पीसीसी डिवाइड बाय 3000 प्लस 0.35। अब फ्रैक्चरिंग टेक्निक की बात करें तो आस्टो एमईपीडी की गाइडलाइन 3 टाइप्स ऑफ फ्रैक्चरिंग टेक्निक्स प्रोवाइड करती है कि रबलाइजेशन, जिसमें एग्जिस्टिंग कंक्रीट पेवमेंट 200 mm से कम साइज में पीस में फ्रैक्चर किया जाएगा। दूसरा क्रैक एंड सीथ, जिसमें फ्रैक्चर्ड पीसेस की साइज 200 से 900 mm होगी। और तीसरा ब्रेक एंड सीथ, जो कि रेनफोर्स कंक्रीट पेवमेंट के लिए ही किया जाएगा। ये डिफरेंट तरीके के इक्विपमेंट्स हैं इंटरनेशनली अवेलेबल कि फ्रैक्चरिंग किस तरीके से करी जा सकती है, और राइट साइड में जो 2 इक्विपमेंट दिए हुए हैं वो हमारे इंडियनाइज कंडीशन में एग्जिस्टिंग कंक्रीट पेवमेंट को फ्रैक्चरिंग करने की टेक्निक है। अब लिटरेचर रिव्यू से हम लोग ये निकाल सकते हैं कि फ्रैक्चरिंग टाइप ऑफ फ्रैक्चरिंग मेथड इज वेरी मच डिपेंडेंट फॉर बिटुमिनस ओवरले फॉर डिस्ट्रेस कंक्रीट पेवमेंट। और जब भी हम लोग इसकी स्टडी करें फ्रैक्चरिंग के बाद तो हमें लाइफ साइकिल कॉस्ट एनालिसिस को जरूर देखना है, और यदि अर्ली डिस्ट्रेस हुआ है पीक्यूसी पेवमेंट में जो कि 30 साल के लिए डिजाइन हुआ है तो हमें उसका लॉन्ग टर्म कॉस्ट एनालिसिस भी करना पड़ेगा। फॉर एग्जाम्पल फ्लेक्सिबल पेवमेंट के लिए परप्यूचुअलिटी के लिए डिजाइन करना भी रहेगा। अब आस्टो एमईपीडी जी की डिजाइन देखें तो उन्होंने डिजाइन अप्रोच में बताया कि जेपीसीपी या सीआरसीपी के ओवरले डिजाइन में यदि हॉट मिक्स एसफाल्ट फर्स्ट आप पार्ट में देखेंगे, हॉट मिक्स एसफाल्ट पेवमेंट में मिलिंग या रेवलिंग या पैचिंग को करके फिर हॉट मिक्स एसफाल्ट किया जाएगा। या फिर दूसरा, जब जेपीसीपी टू जीपीसीपी करेंगे तो आपको उसका फुल डेप्थ रिपेयर करना पड़ेगा और लोड ट्रांसफर एफिशिएंसी सारी रीस्टोर करनी पड़ेगी, फिर उसके बाद होगा। और तीसरा वाले में कि एग्जिस्टिंग पीसीसी यदि ज्यादा ही डिफेक्टेड है तो आपको फुल डेप्थ रिपेयर करना पड़ता है। अब इस केस में हम लोगों ने आस्टो एमईपीडी जी जो अप्रोच है वो डिजाइन मेथोलॉजी देती है कि सबसे पहले आप एग्जिस्टिंग सबग्रेड का मटेरियल निकाल के सबग्रेड की सीबीआर निकालेंगे, या तो डीसीपी टेस्ट से निकाल सकते हैं या मटेरियल वहां से एक्सकेवेट करके उसका लैब में सीबीआर कर सकते हैं, या फिर जो फ्रैक्चर करने के बाद एफडब्ल्यूडी किया है उससे बैक कैलकुलेट किया जा सकता है। दूसरा, आपको हर लेयर का स्ट्रक्चरल नंबर आपको निकालना पड़ेगा कि जो लिटरेचर में दिया हुआ है कि यदि क्रैक एंड सीथ मेथड अडॉप्ट करते हैं तो उसमें लेयर कोफिशिएंट की वैल्यू 0.33 रहेगी। यदि ब्रेक एंड सीथ अडॉप्ट करते हैं तो 0.34 रहेगी। रबलाइजेशन के केस में चूंकि एग्जिस्टिंग जो सीसी पेवमेंट है उसके पार्टिकल साइज 200 mm से डाउन हो जाते हैं तो उसपे FWD टेस्ट करना डायरेक्टली पॉसिबल नहीं है, तो सबसे पहले उसके ऊपर एक WMM की लेयर डालनी पड़ेगी और उसको प्रॉपर प्रोफाइल करेक्शन करना पड़ेगा और उसके बाद FWD टेस्ट करना पड़ेगा और उसके बाद हम लोग इसका एग्जिस्टिंग इलास्टिसिटी मॉडुलस कैलकुलेट कर सकते हैं। फ्रॉम वेरियस एक्सपेरिमेंट उन्होंने फाउंड पाया गया कि जो रबलाइजेशन के बाद एग्जिस्टिंग सीसी पेवमेंट होता है उसका इलास्टिसिटी मॉडुलस 450 MPa से 850 MPa के आसपास तक में वेरी करता है, जो कि एवरेज आउट करके 600 MPa हमारी यदि IRC की गाइडलाइन लें तो 600 MPa सीमेंट ट्रीटेड सब बेस को करस्पॉन्ड करता है। अब अ, हम लोग यदि आस्टो MEPDG गाइडलाइन के हिसाब से डिजाइन करने जाएंगे तो हमारा सबग्रेड का जो मॉड्यूलस रहेगा वो कंबाइंड मॉड्यूलस आएगा GSB प्लस सबग्रेड का, जो कि हम लोग मैक्सिमम रेंज अडॉप्ट कर सकते हैं 100 MPa। और उसके बाद जब हम लोग ने एग्जिस्टिंग कंक्रीट पेवमेंट को रबलाइज फ्रैक्चर कर दिया है तो डिपेंडिंग ऑन द टाइप ऑफ फ्रैक्चरिंग मेथड हम उसका इलास्टिसिटी मॉडुलस अडॉप्ट कर सकते हैं। अब ये दोनों इलास्टिसिटी मॉडल्स अडॉप्ट करने के बाद हम लोग जो भी हमारा डिजाइन ट्रैफिक है उस पर्टिकुलर डिजाइन ट्रैफिक के हिसाब से हम हमारा पेवमेंट डिजाइन करेंगे इन लाइन विद IRC गाइडलाइन, जो कि IRC 37 है 90% रिलायबिलिटी को कैप्चर करते हुए, जो कि उसके हिसाब से हम लोगों ने 4.5% एयरवर्ड और 10.5% वॉल्यूम ऑफ बिटुमिन लेते हुए मॉडिफाई फटीग इक्वेशन जो हो जाएगी 0.7577 इंटू 10⁻⁴ 1/epsilon होल टू द पावर 3.89 इंटू 1 रेजिलिएंट मॉडुलस होल टू द पावर 0.854। अब यदि इसका डिजाइन एग्जांपल देखें तो एग्जिस्टिंग PQC की हम लोग थिकनेस रिज्यूम कर लेते हैं 275 mm, DLC 150, GSB 200 mm और एग्जिस्टिंग CBR 8%। डिजाइन ट्रैफिक एज्यूम कर लेते हैं 200 ms है। अब यदि हम लोग आस्टो की डिजाइन गाइडलाइन के हिसाब से देखें और तो हमारा सबग्रेड का मॉडुलस 66 MPa, सब बेस का मॉडुलस 144 MPa रहेगा। अब हम लोग इसको कंपैरिजन करें, यदि ब्रेक एंड सीथ मेथड अडॉप्ट करते हैं तो उसमें लेयर कोफिशिएंट की जो वैल्यू रहेगी 0.2 से 0.35 के बीच में। हम लोग यदि इसकी वैल्यू इसमें ब्रेक एंड सीथ के केस में 0.21 यदि अडॉप्ट करते हैं तो उसका मॉडुलस हो जाएगा 900 MPa। यदि क्रैक एंड सीथ में अडॉप्ट करते हैं 0.2 का लेयर कोफिशिएंट तो उसके हिसाब से 825 MPa और यदि रबलाइजेशन करते हैं तो उस केस में 600 MPa। हम इन वैल्यूज को अडॉप्ट करते हुए फॉर सब बेस हम इस एग्जिस्टिंग रबलाइज पीसीसी को एज अ सब बेस ट्रीट करेंगे, उसके ऊपर हमारा WMM का लेयर और उसके ऊपर DBM और BC लेयर और ये सारी चीजें हम लोग IIT पेव से निकालेंगे। IIT पेव रन करने के बाद यदि हम लोग पहला मेथड क्रैक एंड सीथ अडॉप्ट करते हैं तो उस केस में एस्फाल्ट ओवरले की जो थिकनेस आती है फॉर 200 MSA वो 40 BC और 50 DBM आती है। यदि इसी चीज को हम परपेचुअलिटी के हिसाब से डिजाइन करेंगे तो BC 50 mm और DBM 95 mm आता है। और यदि आस्टो मेथड के हिसाब से डिजाइन करते हैं कि जो कि पर्टिकुलर हमें स्ट्रक्चरल नंबर के बेसिस पे आएगा तो उस केस में 40 BC और 60 DBM आता है। सिमिलरली फॉर ब्रेक एंड सीथ मेथड 40 BC और 50 DBM आता है नॉर्मल 200 MSA के लिए, परपेचुइटी के लिए 50 BC एंड 75 DBM और आस्टो मेथड से 40 BC 50 DBM। और रबलाइज थर्ड मेथड रबलाइज के केस में करेंगे तो हमारे IRC मेथड से 50 BC और 90 DBM आता है, परपेचुइटी के लिए 50 BC और 150 DBM और आस्टो मेथड से 50 BC और 170 DBM। इस केस में हम तीनों तरफ से देख सकते हैं कि रबलाइज जो मेथड है वो सबसे ज्यादा कॉस्टली रहेगी क्योंकि ओवरले थिकनेस उसमें सबसे ज्यादा आती है। तो कोई भी अप्रोच अडॉप्ट करने से पहले ये जरूरी है कि हम तीनों मेथड का हम लोग कॉस्ट एनालिसिस कर लें। अब हमारे इंडियन कंडीशन में कोई भी एक प्रॉपर गाइडलाइन अवेलेबल नहीं है तो हम इंडियनाइज्ड गाइडलाइन डेवलप कर सकते हैं बेस्ड ऑन द आस्ट्रो डिजाइन अप्रोच। हम लोगों को जो भी टेक्निक अडॉप्ट करेंगे हम लोग डिजाइन ओवरले डिजाइन के लिए तो हम ये जरूर ध्यान में रखें कि हम लोग किस समय पे ओवरले का डिजाइन कर लें। यदि अर्ली स्टेज में कर रहे हैं तो फ्लेक्सिबल ओवरले को डिजाइन हमें 30 साल के लिए यदि रिजिड पेमेंट डिजाइन था तो उसी डिजाइन लाइफ के हिसाब से फ्लेक्सिबल ओवरले डिजाइन हो। और जो भी हम लोग एग्जिस्टिंग पेमेंट में ट्रीटमेंट ओवरले अडॉप्ट करने वाले हैं तो उसके पहले प्री ओवरले ट्रीटमेंट करना जरूरी है ताकि एग्जिस्टिंग जो न्यू ओवरले डालेंगे तो उसके ऊपर कोई भी क्रैक रिफ्लेक्ट बैक होके ना आए। और सबसे ज्यादा जरूरी है कि जो भी हम लोग जो डिजाइन गाइडलाइंस बेस्ड ऑन आस्टो MEPDG जो हम इंडियनाइज करेंगे तो उसके लिए ट्रायल स्ट्रेचेस कंस्ट्रक्ट किए जाए। थैंक यू।
Thank you. Are there any questions? Yeah. Please provide a speak. In the meanwhile,
My question to Swapnil only. So you presented now. Actually, this overlay, what you are proposing for existing road payment, correct? Existing road, we are making existing CC road, you are providing overlay. And we would like to know much about regarding the widening. If I do the same road, widening to 4 lane, if it is 2 lane is there. How about widening when I make the widening of the road? How it acts? Shall I go for CC payment widening and I go for wearing coat as BC, or I go for flexible payment of widening and cover both with the flexible widening?
सर इन केस ऑफ वाइडनिंग प्रोजेक्ट्स सबसे पहले तो हमें कॉस्ट एनालिसिस देखना पड़ेगा कि जो हम लोग उसके ऊपर फ्लेक्सिबल ओवरले डालने जा रहे हैं, जिस भी डिजाइन ट्रैफिक के लिए करना है, तो फ्लेक्सिबल ओवरले की कॉस्टिंग कितनी बैठ रही है, उसके साथ साथ उसको प्री ओवरले जो ट्रीटमेंट करना है, एग्जिस्टिंग पीक्यूसी को आपको रिपेयर करना पड़ेगा, जो भी उसके क्रैक्स हैं सब सील करने पड़ेंगे, उसकी क्या कॉस्ट बैठ रही है। उसके बाद जो वाइडनिंग यदि हम लोग करेंगे तो वो भी सिमिलर टाइप से ही वाइडनिंग करनी पड़ेगी कि एग्जिस्टिंग में नीचे आप सीमेंट कंपोजिशन लेते हुए कर सकते हैं, क्योंकि हम लोगों ने एग्जिस्टिंग सीसी को रबलाइज किया हुआ, तो एज अ सीमेंटेड लेयर हम लोग करते हुए ऊपर फ्लेक्सिबल का ओवरले डिजाइन कर सकते हैं।
Actually, we go for this CC payment for long run. Once we lay the bituminous overlay, it is going to be a stage construction again. Yeah, every 5 years or 6 years, depending upon uh, roughness and all, we have to again overlay. I prefer, like as a layman, I'm just telling, I prefer if there is a CC payment, can be a CC overlay will be better. And
there are
also, if I widening a 2 lane road into 4 lane, then it's easy for me to construction joints or keep it in a homogeneous layer only. It is better, I feel. Please.
I fully agree with your opinion, but then there are conflicts and we have to study in different views, different ideas. The presentation has been made. So please make your point, write it down and mail it to IRC. It is very important. We are coming with a document. We will be needing your comments. Okay.
Sir, excuse me,
Please,
sir.
please have a seat. Please write down and please give your
One,
comments.
next one, sir, actually, for the topic 3.
Please write it down and send it to me.
Yeah,
Okay.
it is there.
There are some comments which I have given to you. Please. आप
Yes,
जरा जवाब
yes,
दीजिए।
आपके पास है।
If you can answer it right now, it's okay. If not, please give it in writing.
सर एक मिनट में लूंगा।
सर
आपका जो सवाल था, सर आपका kindly go through IRCSP 17 which was written by me 2019 में वो IRC ने पास किया था। उसके अंदर आपके काफी सवालों का जवाब है, काफी। IRCSP 17, all these points which you have raised have been dealt by me in that document. Thank you, sir. Okay.
Please write it down. That is very important. Can you?
Sir, there are some observations.
आप mic में बोलो.
Mike, you.
There are some observations from Veera Raghavan sir. First, the title needs correction as rigid payment. Sure, sir. That is the. Second one is IIT PAVE is applicable to fractured slab of size particle greater than 0.3 meter, 0.3 to 0.9 meter, etc. Sir, we have considered the second approach, fracturing of the existing CC pavement for rubberized case. For Indian condition, these different types of machineries are not available. The right one that I have shown, that the jugaad method with JCB is easily available, so we can fracture them with JCB. And the after fracturing, it is necessary that the particle size should be less than 200 mm. After that, we have to seal the surface so that there should be no voids in the existing fractured layer, and it should be a proper profiled surface that can be considered. Sir, that is not mentioned in this. I know, sir. That will be corrected. And
I think it will be better that you write it down
yeah,
and send a note to sir.
yeah, yes, sir.
It will be good for your paper in the future.
Yeah,
evaluation.
yes.
Okay.
Yes, sir. Bilkul sure, sir.
There are some questions for you.
हाँ जी, हाँ, बोलिए।
Sit me.
Veer Raghavan sir has asked some of few questions. I will try those questions. What is dosage of structural additive for the different SMA mixes? As we have done that between dosage study, we have fixed like 0.3%, as we have done for all the mixes that flow between flow test. So we have optimized like a 0.3%. And the next question is, how comparable are the performance of 13.2 mm SMA with 13.2 mm nominal aggregate size BC layer? In this paper, particularly, we are not provided anything regarding 13.2 BC, but we have done many studies. Like we are actually belong to the R&D department. We are regularly testing the SMA or BC, whatever the RUT, as a quality test in our company. As we have seen, there are instances where I have seen the SMA mix, which has meeting all the requirement as mentioned in the IRCSP code, but still the RUT depth is more than the BC layer. So in these cases, when we are studying this one, we have found that there are 2 difference as a Hamburg wheel rut depth. I'll talk with respect to the Hamburg wheel rut. There was 2 difference, like less rut depth in the SMA. But I have seen mixes where the SMA mixes has shown a more rut compared to the BC also. It is a very tricky mixed design when come to the SMA. When the third question sir asked is, when gradation of S curve do not vary significantly, how the OBC is vary and whether it cracks. As it has been a preliminary study, we have observed that there is a difference in OBC that may be due to the better. We have seen that the VCA dry also got reduced, VCA compared to that of the S curve. Because of there is a less VCA almost in the dry one, the binder is required less to reach the VCA mix, which is less than the VCA dry. It may not be the optimum the answer, but what I can reply for this one, this is the answer. And when it comes to the crack, as binder is not that much vary as the point already that more than the what is the BC normally we are laying. I think the cracks may not appear. When the last question is, what is the recommended thickness of 9.5 nominal aggregate size for SMA? We have not given any thought on this one as of now, but still many people has to be studied. It is a single laboratory study, so we cannot propose directly thickness. But as we have 30 will be optimum because it will be around 2.5 times the nominal aggregate size of the aggregate. Thank you.
Last question will be replied by Dr. Viraraghavan sir, and then we will conclude.
There are two questions from Venkatesha. The first question is on the field mix designed with 50 blows. Is there any variation? Is the same mold size? The mold size remains the same.
Yes, sir.
Only the number of blows changes from 75 to 50.
Sir.
Wait.
Yes,
Let
sir.
me answer your question.
Okay, sir.
The second question, what you're telling is open graded premix carpet has to be mandatorily stopped. Then only this thin lift witness is successful. Need not be there. It is all specifications are in that. It is for you to choose. If you are a concessionaire, if you're a contractor, if you want a longer life payment, you can choose this or you can maintain every year also. It's up to you. We said all these options are available. And successfully, we will be removing previous carpet, mostly from the ministry specification. But still, many people want, so it is retained. It's for you to choose, not to choose.
So regarding this blows, actually for NMN 19, same blows we are maintaining and same mold we are using, sir. And NMA 13.2 also same. Why 9.5 NMA there is a reduction in blows?
You have to read the paper which I have published. Then you have to read the MS2. Then you'll understand both. You'll get an answer to your questions. Like you have to read MS2.
Done, sir. That's thank you, sir.
Sir, I have a small question. When we can look at as I've seen lower blows will result in a higher OBC. We can go for the low volume roads or different gradation which can attain airwards desired airwards at the lower binder content, so that as we know OBC is already giving the sufficient durability and the fatigue for BC layers. So when we go for low volume roads, we can opt for the different gradation, so that
there's a relation between the nominal maximum aggregate size and the layer thickness. So when you want to have 30 millimeter as the minimum thickness or 25, the nominal maximum aggregate size cannot be lower than 9.5. People can come with research papers, laboratory research, but in practice, it should be 1/3 to 1/4 the layer thickness. You can have 4.75 also. You can have 2.36 also, but that will not work in the field. Absolute minimum that is preferred is 9.5 when the thickness is around 25 millimeter to 30 millimeter.
Ladies and gentlemen, now let us sum up. We have my co-chairman colleague, we call him Bhishmacharya of PWD. This 82-year young man with us is going to, as my co-chair, is going to sum up the issues. I'll request him to.
Thank you. 82 years young. Perhaps oldest in
82
this,
years young.
perhaps oldest in this hall. Regarding paper number 728, I encountered, rather I was presented this SMA paper in Australia in Royal Melbourne Institute of Technology, one by Mr. Hans from Germany. From there I learnt it. It's a good technique. It has been used. It is being used by NHI on all. My only observation is that somewhere I will not name the projects. The quality control is an issue. Now regarding the paper itself, there is a question from myself to the author. He has compared 13.2 millimeter size and 9.5 millimeter size, and the language used is that they are comparable. What do I mean by it? This comparable, it is not a very strong, we should be specific. Were the rating reduced by increasing the size or not? That is specific question. So kindly, the author of 728 may oblige me. You are there, sir? Kindly tell me, was the rating reduced or not? Because NHI has adopted this specification due to rating. So kindly tell me, this is a big issue.
Yes, sir. Rating. Sir, rating compared to 13.2 mm, rating was little reduced.
It was used.
But the difference is the gradation, sir. In 13.2, 9.5, and 4.75, we use three different gradations. That is S curve, mid curve, and inverse S curve. So inverse S curve was giving the most least rating.
So okay, then in 728 you have taken all this and volumetric, mechanical. Now another is regarding cellulose fiber. In all these you use 0.3% or you varied it. Okay. Otherwise, it is a good paper. One should go through it, and it is being used by NHI in all projects, mostly as a. Now, next is by Sri A. Veera Raghavan. Veera Raghavan साहब
Sir.
है क्या? और देखिए, you have talked of air whites after 4 to 6 years, 6.5, and higher binder content increase the mix's resistance to age-induced cracking. But how much percentage I do not find in it. Kindly elaborate.
So when we are reducing the compaction effort, the optimum binder content was actually found to increase by about 0.4 to 0.5 percentage. Now this would actually improve the durability characteristics of these mixes. So in the case of low volume loads, we are concerned about durability.
Then it is 5. You have also compared 75 blows versus 45 blows.
Yes, sir.
It's the 45 blows is something new to us, and it's a very good.
Yes, sir.
It's a very good innovation.
Thank you, sir. Yeah.
Congratulations. Then we go briefly to comparative analysis evaluation of black spot. Before I comment on it, I will request the investigators to go on either EP or any other highway at night and see all the trucks are going in the car lane. Nobody is studying it. Its impact is so many accidents. The car fellows are crushed. It's a big issue. आप रात को कहीं भी चले जाइए, सारे बड़े बड़े ट्रक और टैंकर वो कार लेन में ही चलते हैं, अपने में चलते नहीं, या मिडल वाले में। बाकी आपका जो ब्लैक स्पॉट का है, इट्स अ वेरी गुड एनालिसिस एंड यू हैव सेड द IRC latest document of 2022 evaluation of black spots is an ideal document. We should follow it, so no doubt. Then you have given geotechnical model regarding geometry. This is different. Then AATC is same. Then we go to uh, what was that, sir? Study in. You have said limitation is that the study was carried out only in a length of 500 meters, isn't it? So this can be and should be increased. That's all. Now regarding this overlay, sir, with your permission, I will take couple of minutes. This is a pet subject, concrete road mine, and IRC SP17 should be gone through. But as a matter of precaution to all the brother engineers sitting here, when you do overlay on a concrete road, two phenomena occurs. The coefficient of thermal expansion and contraction of the lower layer underlying concrete slabs is more than that of the bituminous layer. Resultantly, if you do it like this only, after some times, the joint opens and water enters. And when the vehicles fly, because of the pulsating action of the vehicles, the bitumen becomes emulsion and it goes on widening and widening. So the better thing would be to first, this is what we experimented on Akshardham in Delhi. Fill the cracks, fill the joints with 6% bituminized sand, then lay geocomposite glass grid, geocomposite glass grid, and then you do your treatment. We have seen it from last 2 years, sir. It is behaving very well. And if somebody needs, give me email, I will email the specifications. And now regarding the paper itself, crack and sheet, crack, Atashi is here, I think she presented, she has done lot of research on it and her this thing was presented yesterday. Hopefully it will make the approval of the
Sir,
council.
what she needs is the specifications for joint filling. So probably I'll ask her to discuss with sir and get them. That can be included, so there will be no problem.
So thank you very much, sir. And for this is a very ticklish. And now NHI, without seeing, धड़ाधड़ वो काली सड़क बनाई जा रही है सफेद को. There are options. किसी ने सवाल किया था वहां से कि किस परसेंटेज पे. I have written in that IRCSP 17. 10% से यदि ज्यादा खराब हो तो do unbonded, otherwise you do bonded. कोई और किसी को सवाल हो तो he can email me, I will reply.
Sure.
Thank you.
I thank my co-chairman and I'll request the management to take over, please. We have a very interesting session and all the poll papers deserved a meritorious attention. They got it. We congratulate the authors.
थैंक यू सो मच सर। और एक छोटी सी प्रथा है, उसका निर्वहन हम करना चाहते हैं। हम सभी माननीयों का स्वागत करना चाहते हैं, अभिनंदन करना चाहते हैं। इसलिए नाउ आई वुड लाइक टू कॉल मिस रितु खरे, एग्जीक्यूटिव इंजीनियर पीडब्ल्यूडी रायपुर। प्लीज मैम कम ऑन द स्टेज टू गिव बुके मोमेंटोस टू द ऑल गेस्ट सिटिंग ऑन द स्टेज। सबसे पहले मैं रिक्वेस्ट करूंगी चेयरमैन श्री सीपी जोशी जी से
ये तो मिल गया था पहले. बेटा दो का क्या
कि
करेंगे?
वो बुके और मेमेंटो प्राप्त करें। साथ ही साथ को चेयरमैन श्री आर के जैन जी, इसके बाद श्री विश्व विकास राव जी, श्री प्रोफेसर विष्णु राधाकृष्णन जी और डॉक्टर A.V. वीरा राघवन जी। श्री देव सिंह ठाकुर जी। और मिस्टर यश पांडे। और हमारे साथ हैं श्री किरण तोगंशी जी भी। अच्छा। और साथ ही साथ हम सम्मानित करना चाहेंगे डॉक्टर रवि शेखर जी को भी। डॉक्टर रवि शेखर, चलिए। थैंक यू सो मच सर। आप सभी का बहुत धन्यवाद अपना समय देने के लिए, वक्त साझा करने के लिए। और इसी के साथ इस सेशन की समाप्ति की घोषणा करते हुए अगला सेशन हमारा ठीक 4:30 बजे से शुरू होना है, तो उसकी तैयारियां करते हैं और एक बार फिर मुलाकात करते हैं। थैंक यू।
सर ये सूरज को दिया दिखाने वाली बात कैसे हुई? टीम का ऊंचा चाप इंजीनियर कैसे टीम का ऊंचा चाप इंजीनियर। And my subject is concrete roads. From 2000, in 2004, I brought the technology of white topping to India from Federal Highway. Only engineer from India who has visited Federal Highway, and my topic is concrete roads. Thank you.